So today I'm going to be talking about some of the lessons I learned migrating a static website from the static site generator Jekyll from the Ruby community to Next.js, and kind of the journey I took for my company's website to go through that process. So, and how I used Playwright to kind of help along the way. And for entertainment purposes, we're also going to have some corgis, just because. So, platform migration. So this is a discussion about migrating from one platform to another. So we have, one static site generator to another static site generator, and I love platform migration projects like a lot. Like I get really excited about them. I think they're a lot of fun. And this is a question that I like to ask for a lot of talks that I give. So, who in the audience is a software developer or kind of identifies as a software developer or works with code? Okay, awesome. So, who here enjoys working on a project they inherited from somebody else? Okay, all right, so some maybes. Like, those are my favorite projects. And I like doing that work so much that I started Corgi Bytes, thus the corgis. And that's all we do. We take systems that other people have built and we make them better. And better can be migrating from one platform to another is an example that comes up a lot. And so thus this talk. So we've done a lot of platform migrations over the years. And we've developed a philosophy that I really like to use with these projects. So doing the initial migration step, so migrating from the initial platform to the other initial platform, there's almost always things that you want to make better along the way. There's some reason that's motivating you from going from one to the other. There are things that you want to improve and make better, and it can be really tempting to try to cram these two ideas together. We're going to migrate from platform A to B, and we're going to completely design the look and feel. Or we're going to build in 10 new features while we do this. That can be really tempting, and it can be like, because you're hoping that the new platform is going to make things easier, especially for solving some of the challenges that you've identified, it can be really tempting to try to do both at the same time, but it makes it very difficult to validate whether or not you got the migration correct. So with no visible changes, you then have the opportunity to validate that you performed this migration correctly. Also, finding some way to do this work gradually. So taking the work that you're doing and having some kind of way to measure your progress. So if you can put the work that you're doing, like the replacement in a staging website, or where your customers or whoever you're collaborating with can see the progress you're making along the way, like that's really important, because a lot of these platform migration projects die when managers see no results for months, right? Like they just hear, you're working on it, you're close, we think we'll be done soon, we think we found all the problems that we're going to run into, you haven't, right? There's always one more problem that you haven't anticipated yet. And being able to show that progress is really, really crucial to keeping the project alive. So many platform migration projects die as a result of this. Also, utilize automated testing to guide this approach. So find some way to utilize test automation, even if it doesn't already exist, to guide the approach that you're taking. So it's really kind of the underlying philosophy that is kind of like baked into the way we like to do things. So corgibytes.com, we launched it 10 years ago, built it with Jekyll. It's hosted out of an S3 bucket, and kind of the motivation for hosting out of an S3 bucket was so it was kind of infinitely scalable, without us having to build anything infinitely scalable. Brian talked earlier this morning about scalability. Yes, it's something we cared about. Yes, it's something I cared about. It was really just me at the time. And it's something that I was nervous about. I was nervous about, like, what if Corgi Bytes gets mentioned on Oprah, right? Or what if Corgi Bytes gets trash talked on Stack Overflow, right? Just assuming that nobody would say anything nice about us on Stack Overflow. Like, look at these idiots working on legacy code projects, right? That's kind of what I was expecting. But I didn't want an event like that to completely crash our website and then embarrass us twice, right? So if we're getting bad mouthed and like, oh, these idiots can't even keep their site running, like that genuinely kind of worried me and kept me up. I wanted to make sure that that wasn't a problem we were going to have. So by hosting static content out of an S3 bucket, then I can rely on all of the infrastructure and hard work that Amazon has done to make sure that those sites stay up. And yes, when there's an S3 outage on the East Coast, our site goes down, which is no fun because there's not the failover story for hosted S3 buckets isn't so great, but that only happens once every couple of years, so we deal with it. But this kind of opportunity we wanted to migrate our website because Jekyll had worked really well for us for a while. We had hundreds of blog posts that we put out. I think close to 1,000 blog posts that we put out over those 10 years, and just built up this really large corpus of content. And all of the content on our website was really driven by the way Jekyll lets you organize information and create what Jekyll calls collections. So Jekyll has this like data model that you can create where you can create your own object entities. And so we had one called team, and all of the entities within that are markdown files. And so it's just like a special directory called _team. And within there are markdown files for all of our team members. It's a markdown file. It's got some metadata at the top for like the team's name, the team member's name, their LinkedIn profile. We pretty much had like a NoSQL database, at the top of the file with the metadata, and then a description and markdown of that person. And then we're able to build templates using Liquid to loop over that content and render each team member. So like everything on our site was built this way. Pretty much all of the content we had living in one of these folders, and that's really how blog posts work in Jekyll as well. Is each blog post is kind of a special collection type with some known attributes like title and publication date, things like that. But we really started to feel like it was time for a change, and there were some goals that we had in mind that really kind of motivated us wanting to move into a different direction, and a lot of that really had to do with the way the HTML was composed. Jekyll and Liquid work really well for the problem that they solve, but handling duplication is not one of the problems we felt it solved, and felt like a more component-based approach that had certainly evolved out of the web community was one that we really wanted to take advantage of. So we had our eye on React and Vite and tons of other component-based technologies, even web components. We looked at lots of different options. Wanted to remain static. Really liked the benefit of being static. It was tempting to move to something that was rendered entirely on the client. To something that was like kind of a hybrid between server-side generated and, but figured that like accepting the constraint, if we're going to stay static and really like decide that we're going to live within the constraint can be painful, but it's one that we just kind of decided to operate within. I also wanted to make sure that I didn't want to have to change every single blog post. I didn't want to have to like copy every single blog post into a new format that some new blogging tool or some new static site generation tool that we're using would require us to transform all of our blogs. I didn't want to have to deal with that. I wanted to find a way to not have to take all of this collection data that we'd built up and morph that into a new format. So we had to pick the right tool to help us deal with these constraints that we kind of put in place. And so like that was kind of like our why, again, speaking back to Brian's talk this morning. So we considered a ton of options, all of these at least, probably more. There's a website Jamstack. I don't know if any of you all have come across that before, but if you've got a JavaScript asynchronous, or what does Jam stand for? I forget. Anyway, there's great place to look and browse for your next resume-driven development project, right? Like tons of tools that you can at least look at and evaluate when you're trying to figure out like, okay, what tool is out there that might solve the problem that I have, and really kind of evaluating those tools and figuring out, what's gonna make the most sense. So looked at all of these, and really kind of settled in on Next.js, in part because of its like tight, it is React. That is what it is. Like, you don't really have the option of doing anything else. It's Next is an opinionated React framework, and we had a pretty high level of comfort on the team already with React. So even though React is, not as sexy as it used to be, it's certainly not doesn't have the biggest fan community. I saw an article a few weeks ago where somebody said it's like IBM. You're not going to get fired for picking it, but it's certainly, it's not the most exciting anymore. So that's why we went with that. I felt that Next's static site support was really good. So, and it had good support for other use cases as well. And so if we did want to move in the direction of hosting the application within a node process, because Next.js leans so heavily on rendering as much static content as it can, and then using progressive enhancement to then render on top of your static content, felt like that was a pretty good approach that we might move in the direction of if we wanted some more dynamic content than we've had. Also really liked the app router that came out with Next.js 13. We started working with it before 13 was published completely. We were working with early previews of it. Really like the server components approach. That's still kind of experimental in React, but it's definitely baked into Next at this point. And the file-based routing really made sense for the problem we were solving, because we're trying to render files that are already on the file system. We just want to render them slightly differently. And so taking a file-based approach to the routing really made a lot of sense for our use case. And so like having to build another router or having to like migrate our content into another router really would have felt like duplicate work. We also found a blog starter project that the Next.js project maintains. It's actually an example in the Next.js repository. And started with that and kind of really learned from some of the ideas that they had. Where basically what that starter project does, if you go and take a peek at it, they had a folder for the blog post and markdown files, and those markdown files had metadata in them, very similar to the way Jekyll stores its content. And so I was kind of like, I can adapt this to solve the problem in the way that I want to solve the problem. So once we had kind of like settled in on our technology, I really wanted to kind of look at like, okay, how am I going to validate that we've done this correctly? What am I going to do to make sure that this migration has been successful and kind of meeting that goal of like, I don't want any changes that a customer would notice. Like really small, slight changes are acceptable. Like it doesn't need to be exactly pixel perfect, but it needs to be pretty darn close. So decided to use Playwright and really lean on the screenshot comparison support that Playwright has. And focus in on capturing screenshots and comparing screenshots for critical pages across the site. No need to hit like every single blog article, right? Just look at one article to be kind of like representative. So it's got like some code in it, so we know that the code samples are rendering, the code blocks are rendering correctly. We know it's got like a header image, that we know that those are rendering correctly. Its tags and category links, its author bio information, all of that stuff's rendering correctly. I also wanted to test at multiple viewport sizes because I wanted to make sure that as part of doing this migration, that it didn't just work for the desktop, that it also, everything still rendered correctly for mobile users as well. And I wanted to make sure that all of those different viewport sizes that are, that can come up for a public website, that those were handled well. And multiple web browsers as well. So especially different web browser and viewport combinations. So like Safari at an iPhone size, Android, or like Chrome at an Android device size. And Again, kind of going back to that pixel perfect thing, allowed like 2% variance in the screenshot comparisons that I did. Also validated page metadata. So looking at the title, the viewport, the open graph metadata that can be part of a page, making sure that those things get replicated correctly. And then also validating the content of the RSS feed. My goal is that if you do happen to subscribe to our website in an RSS reader, that us doing this migration isn't going to result in every single blog article becoming unread, right? There's few things that are more frustrating than that when you're subscribing to a website with an RSS reader than when they do a migration and now you've got all of these old posts showing up as new. And I wanted to use production, like the current production, like CoreGigabytes.com website as the initial capture. So not something that I'm doing in a development environment, but like what's actually live. So here's what the code ended up looking like. Hopefully that's somewhat easy to read. Bits and pieces of code snippets. It's really kind of hard to show all of the code, and this isn't a code base that we've shared publicly. I'm not sure my comfort level in doing that, but like if we do decide to do so, then I'll put out a message on Mastodon that says that, and you all can take a peek. I'm really on the fence about that. I don't. There's not really anything in there that's not already on the website, so I don't know why I'm hesitant. But yeah, anyway. So these are the pages that we decided to hit, and kind of called them test points. And then this is the test for Playwright that loops over every single one of those. And I don't think my laser pointer is going to work. Oh, will it? Maybe. Aha, okay. So here, it's looping over that test point array and then creating a test for every one of those test points. And so for each one of those, we're visiting the URL, where we're removing content that we know is dynamic and is likely problematic. So on our blog post, we had an integration with Discuss. We can't control the content that Discuss puts out. So we can't control like what recommended articles it puts out or anything like that. So just detect that div or that iframe and then hide it so that it doesn't show up. The same for like the reCAPTCHA that shows up on our contact form, hide that so it doesn't show up because we can't really control the way it renders. And there was another like integration we had for like sign up to our newsletter if you haven't visited the site before or something like that. So hide that as well. But then visit the page, grab an initial screenshot of the current viewport, and then scroll down through the page all the way to the bottom, taking a screenshot each way along the way. Now, this is something that we decided to do because of a limitation in Playwright on Linux with capturing the entire page in one go. So there is a way you can use the screenshot capture function, the to-have screenshot function that's right here. This one. You can tell it to capture the entire page, like top to bottom. But that for a really tall page, especially at a small viewport, so if it's like a mobile display, that could be like, 100,000 pixels tall, right? And the Cairo library that is used on Linux to do the image transformation has a limit of 65,360 pixels. So this was a way to work around that by just going through and capturing a page at a time. That also meant that we were less sensitive to slight pixel differences because 2% of a smaller image is less of an impact. Anyway, it felt like it was a better fit. So this approach did come with some pros and cons. So on the pro side, we really had high fidelity and confidence that what we were creating was going to match what we already had. It also gave us the ability to do progress tracking because the tests that are passing, those are the pages we've gotten done. And so we're able to kind of like, really track our progress along the way and see like, oh, it's working, but not for mobile viewpoints, viewport sizes. These are pages we don't have done yet. Oh, we're missing the metadata on this particular page because we had a different test function that checked the metadata. But there were some cons to this. And so one was we generated a lot of images. So for all, I think we were testing 20 different viewport sizes, and all of those pages. So you multiply that out, and then each of those pages we're scrolling down through the page. So for some pages, I think the About page for the iPhone, it's 65 images just for that viewport size. So lots and lots of images, nearly about 650 megabytes of images that are generated. Git LFS was an absolute must for this because we wanted those golden master images checked in the repository so we could run these tests in continuous integration, but they take up a lot of space. So there's definitely one downside to this approach is you do end up having a really large repository that you have to manage and figure out how you're going to manage that content. It's also time intensive to run these tests. Multiple cores certainly helps. And so on GitHub Actions, which I'm using, the tests on the vanilla GitHub Actions worker took about an hour. And that's a two core machine. I changed that, I upgraded that to their 32 core machine, which costs 1.8 cents a minute. And it ran in 3 minutes. So okay, I'm willing to pay 6 cents a build to make sure that I don't have to wait an hour, right? But there is a trade-off there. You have to spend a little bit of money. So how did the actual implementation for the Next work? So again, this is the process we took at a page at a time, and run just the test for that page, isolate the test for that page. Created a next page component for that page, so for the About page /about page.tsx. Completely copied the Jekyll HTML for that page, which was usually pretty ugly, and inlined any templates that it was using into that page, and then that resulted in a whole bunch of compiler errors because, for example, class is not valid in a TSX file, so you have to rename all those to class name, which you can do all at once. But lots of other little issues as well, Jekyll was much more, Jekyll was not doing any syntax checking on the HTML content, where a TSX file is much more strict about making sure you close tags, for example, on a paragraph and things like that. And then we created little API functions for accessing any of the content that Jekyll was using, was pulling from collections. And we migrated any content that was static into a JavaScript object. Really thinking about where we might go in the future, if we decide to move in the direction of a headless CMS, that's content that we wouldn't want inlined in our template. So putting that into a JavaScript object and then injecting it is the decision we made. So once we had that, and then would run the test and make sure that renders correctly, would then created components to reduce duplication. So any duplication that we saw in that page, or anytime we wanted to loop over something, that would be an obvious candidate for us to extract out a React component to wrap that concept. So this is an example of a Jekyll collection. This is the Jekyll collection for our team. And so here you can see the team folder and the different markdown files that are in it. And then here's the markdown file for me. You've got the attributes at the top, and then the bio as the body in the markdown file. And this is what part of the Jekyll looked like. I cannot fit it all on the page. It's a giant file. This is the bit that looped over team members on that page, and then it emitted the HTML. And it's a pain to work with. Liquid at the time was awesome, but it has not aged well in 10 years, especially when compared against other web frameworks and other web tools. There are certainly better ways to do this now. And so after we added in Next and React, like I can pretty much fit the entire about page on the screen. There's only a little bit that cut off, like maybe like 3 or 4 lines that got cut off in the screenshot. And we were able to like extract out lots of components for things that kept coming up again. So like our sections, were formatted the exact same way across the code base, but like that was copy and pasted in every single one of our Jekyll templates. So you can see here a couple functions that are being used up here at the top. If I can get this. So there's a get about page and get core values and get team members. The get about page content just looks like this, and it's really just kind of pulling in that JSON description. So this is like the static content that shows up on the page that's then getting rendered in. And then this is the function to actually get the team members. And so again, like this is kind of like the API function. So this is like getting the ultimately hitting the file system to get the team members. And then so here's the code for like loading a single team member, and then right at this point, taking the markdown and rendering it to HTML. And then here we're actually loading the contents of the file off the file system. So, and here is loading a blog post. And I wrote this function for just getting a general kind of Jekyll collection and read it into memory. And that's what this looks like. And using the React cache library to memoize the results on a per request basis. So to try to limit the number of times the file system is getting hit for the same information over and over again, especially when looping, especially anytime things were looped over. And again, the markdown's getting handled here as well. And there are a few different libraries that ended up getting used to handle the markdown. There are lots out there. So again, pros and cons of this approach. Pros, almost no changes were required to any Jekyll collection or blog post. I think there was like a description I needed to add to a few blog posts that didn't have a description. In that, I could have checked to see if it was there. It was honestly easier for me to add it to 6 files than it was to handle it sometimes being there. And it laid the foundation for migrating to a headless CMS, which is kind of where I want to take this next. But certainly cons. One is performance. The caching of the file system, like retrieving all that content off the file system, only happens once. And for blog posts, if I need to render a category, if I need to like get a list of categories, so like on the blog post view, we have like a list of categories that you could pick from to like see another category on a blog post page. Those categories don't exist on their own. They only exist as like tags on every blog post. So in order to get a list of the full list of categories, I have to visit every single blog post file in the file system to get that. And then that only, like I'm able to cache that in memory, but for the next request, it all gets read again. So that was definitely a challenge. That also means that in dev mode, when running the Next.js site in dev mode, it takes like 3 seconds for a blog post to load. So it's definitely not ideal. A way to work around that is to build the static site, and then everything renders really quickly because it's being served statically. You don't have to wait for Next to build it dynamically. But the builds are slow, and more cores certainly help with that. But on my Mac with like 10 cores, a build takes like 5 minutes. And that's just like way too long to wait. So I definitely want to figure out a way to make that faster. So for deployment, like I mentioned earlier, using GitHub Actions, first creating a static build, and then starting a HTTP server, and then using that for running all the snapshot tests against it. And that runs really, really quickly. So all of the snapshot tests running against the static web server is way faster than having all the snapshot tests run against the dev server. And I'm running out of time. Then publish the AWS, invalidate the CloudFront cache. Future, migrate to headless CMS. Want to refresh the design, it hasn't really been changed in 10 years. Improve performance, remove unused stuff. All right, so that was kind of where we'll went at the end. This is me. If you want to chat more about this, or maybe get to know Core Gigabytes a little bit better, on May 16th, there's a virtual conference we're holding called MentorCon. This will be our fifth year. And this is a conference kind of focused on legacy code. We describe developers who like doing the work that I talked about earlier as menders. So if you think you might be a mender, maybe a closet mender, because you could tell earlier it's not popular to be a mender, you can check that out. I also have a podcast that I host called Legacy Code Rocks. We've got like 155 episodes, something like that. You can take a peek. And I don't have questions, but that's the end. And if anybody gets the joke, that's the end. And then all the images are here. So thanks, everyone. Apologies for going over time. And so I don't know what the schedule is. Do we have a break next, or?
You can take questions for like 5 minutes.
Oh, I can take 5 minutes of questions? Okay, all right. We're ahead, okay. All right, I raced through for nothing then. All right, all right, so does anybody have any questions? All right, Brian.
Yeah, you mentioned adding tests, or being guided by tests. How do you add tests when there aren't any?
So.
In like legacy code.
In legacy code? So I like to be informed by I really like the test pyramid metaphor, and creating a well-balanced, making sure that your test pyramid is well-balanced. So generally I like to start out with like creating that first stone. So like if you don't have a pyramid, right, like you don't have one yet, the first stone is the tip and the bottom of the pyramid. So make that an end-to-end test. So it's the first one you add is an end-to-end test. And so in this case, I added a bunch of end-to-end tests, right? I pretty much added only end-to-end tests. So then the next set of tests you add, you then start kind of building out the layer that's down below. So then start building out some integration tests, then start building out some unit tests. And looking at the end-to-end tests that you have and seeing, can I defend against the bug that this is defending against in a lower level test? And then you can, if you can convince yourself that you're defending against all of those bugs in a lower level test, then you can remove some of the acceptance tests that are or some of the end-to-end tests that are ultimately slower than the unit test would be. But only if you're able to build up that level of confidence that you're defending against the same bug. So, in the back.
Yeah, I'm curious if you stumbled across the documentation for Next.js's unstable cache function. It might help with some of
the unstable cache? Yeah, so I looked at that, and I forget what the default provider is, but it didn't look like it was going to fit well for our use case. I found a library that has like Redis available, and it also looked like the invalidation of it could be a little tricky. But that might be something that I do, although it does seem a little silly to spin up a Redis instance just so that I can do a build and do a build quickly. But that could certainly be a solution, and it's worth exploring. Thank you for that. Anyone else? Oh, yeah.
Yes, you talked a lot about testing, like from a visual perspective,
Mm-hmm.
between the old site and the new site. How would you go about testing like functionality, or like I guess more heavy functionality than just?
Yeah, so more heavy functionality. So like on our site, like the heaviest functionality we have is like on the mobile view, we've got like a hamburger menu that flies out, and then we've got a contact form. So for that, for the hamburger menu, we have a test that like simulates asks Playwright to click on the hamburger menu, and then it waits for that slide to come out and then captures a screenshot. And so we're kind of like some of that more dynamic content that shows up. So like simulate user activity to actually make it show up, and then handle it that way. And then for like our contact form, we're mocking out the backend that we communicate with, and then using Playwright to simulate filling out the form, clicking submit, and then making sure that the correct response to the backend is actually generated. So, all right, and we're done. So thank you.